Hello everyone, how are you? Today I am going to discuss about a very important topic of Terraform known as state file. So what is state file? How is it used? Why is this so important? How can we store this state file locally or remotely? These are all the main topic of this video that I am going to discuss. I will focus mainly the issues that we face during our development with Terraform and its state association. Other than that, I will give also one concept about state file, how can we use it in various way. If you have not seen the introduction video of Terraform, kindly do watch that and you will get an idea about Terraform. The link is above and in the playlist of this video. Lastly, if you are new to this channel, kindly subscribe, like, share and comment your thoughts and enjoy this video. So let's go and start our state file journey.
So what is Terraform State File? Well, $1 million question, and the answer is very simple. This is the source of truth of our current, past, and future. By state file, we can observe and decide when in our infrastructure one EC2 instance has been changed to 3 EC2 instances. So it holds the information about current infras deployed to our cloud. This information is very vital in case of disaster recovery, new deployment, or to destroy any resources or to update our resources. Now, the next question is why it is important. From my previous note, you might have get an idea about why this is so much important. Still, I have made some pointers. So this holds information about the current, past deployment and resource provision. That's why I would like to call it as a source of truth of our infrastructure. So state file is the backbone of our infrastructure. It prevents code drift. If any manual modification is done and we don't know about it, we can always come back to the base version. This is very important. I have seen many cases in enterprises where they have code drift and it cannot be undone because they do not use Terraform state file. With state file locking, we will have parallel execution possible. We will talk about it in details. We don't have to create it. The state file is created automatically when applied. So we can store our state file either remotely or locally. The state files should be isolated from change to reduce the blast radius. Means we should not change it manually and keep it securely, as if this compromised our base infrastructure is gone. Now comes to the part how to use it. We can use it by two ways. One is locally and one is remotely. In locally, the state file can be kept in user machine or in the code repo, and every time deployment happens, we can refer to the state file. This works, but it has a tremendous negative effect. As this is locally managed, it can be compromised. So it's not secure and not an industry standard. Another way and most used way of doing it is to store file remotely. In our case, in AWS world, we will use S3 bucket to store our state file. This is very widely used and also robust and secure. Now for our remote storing, we will also look into how we can process it parallelly and deploy our code. So it works in multi-developer environment. With DynamoDB locking, we can do it. We will also look into that. So in next part, I will show you some of the industry best practices of state file and how can we be benefited with it. As again, this is more specific video of a Terraform state file, how industry uses it and most known issues and resolution. So let's go and create some infrastructure with state files. So I have opened up the same code repository that I have used in my previous tutorial about introduction of Terraform. So if you have not watched that video, please go ahead and check out the video. It will give you an understanding how Terraform works and the introduction of Terraform. We will not go through that again. I have opened up the same repository with PyCharm. What we are going to do here, we are going to introduce I am going to show you what state file is and how it is being created. Now, first of all, this repository I have opened and also I am inside this repository with my terminal. First of all, we have to do we have to configure our AWS credential. So to deploy the code in AWS cloud, we need to configure the credentials of the account that we will use for provisioning the resources there. So for that, we need two AWS credentials configured. So we will do it with AWS configure command. And if I do this one, then it will ask me for AWS access key ID. Now we have to give access key ID. I will give my access key ID now. And this is my access key ID. And then it will ask me for secret access key. So let me copy that one as well. And this is my secret access key. And I will keep the default region as it is. And that's it. So my AWS configuration is done. Now, if I deploy something here, it will be deployed to this account that I have configured, and that's it. So we have configured AWS credential. Now the main part is that we have this repository, our blank repository, and what we are doing here, if we go to our main.tf, we are creating one S3 bucket, and this is the bucket.tf where we are creating one S3 bucket, and we are provisioning the S3 bucket to be public access to be blocked. So my public access is blocked. This is what we are doing entirely, and we will now manage this one with Terraform. So first of all, if you remember from our previous tutorial, what we have to do, we have to do Terraform init. So Terraform init will initialize the modules and the provider version and everything, and it will also, let's go to the workspace now. So what it will do, you will see here. So first of all, it has created one .terraform file for .terraform folder where we have the modules and the provider installed, and everything is successfully done. So this is the work that Terraform init has been Terraform init does. And also it has created one log file so that the provider and Terraform, no one changes this one in the meantime. That's fine. So after the Terraform initialization done, we have to do Terraform plan. So Terraform plan will also show us what is the plan of deployment for the infrastructure that we have given in the code base. So if we do Terraform plan, so it will show me the resources that it is going to create. So now this is my plan. So what it says that it will be created what, an S3 bucket. An S3 bucket will be created, and everything is create. And another one is that the public block access setting will be created for the bucket itself. So these are fine. So plan to add. So as of now, just see the workspace now. Till in my workspace there is no tf state file. As soon as I type in Terraform apply, it will create now the tf state file. You see here we have terraform.tfstate. The state file is created, and terraform.tfstate lock info. The lock info is also created. That means this currently this deployment is locking the state file. As long as we have the deployment is done, this will lock the state file. And if our deployment is done, then the locking will be gone. Now as it is, it says me, can you validate? Okay, I am validate. So validating, go ahead and deploy these resources. So as long as I type in yes, you will see some changes here. Just look at this one. If everything is done, if we come here, oh wow, now my tf state is there, but the lock is gone. Terraform tf state lock is gone. That means my tf state is now again modifiable. This is very nice. And we can see if we go to our infrastructure, go to S3 bucket, we see that the bucket is created, and permissions, everything is public access is blocked. This is nice. And our tf state file is also created. Now what is this tf state file? So if I open this state file, we will be able to see a couple of information. So first of all, the version information, the Terraform version information that we are using, the serial number, and the main part is the resource. Here in the resource section, it will tell us how many resources will be provisioned with our infrastructure. So here in this resources, I can see there are two resources will be provisioned. One is this one is module, and another one is the S3 bucket. So this is the S3 bucket, and the name of the S3 bucket is Beyond the Cloud, and the ARN of the bucket domain name, prefix if there is any, and other than that the default encryption. So these are all everything related to the bucket will be shown here. And apart from that, the second resource where we are creating the module, this one, where we are creating the public access block, this will also show here S3 public bucket access block, and this is for which bucket. It will show you this is the bucket ID, and this is the same thing for the first resource, and this is for the second resource. That means our state file holds the information what has been deployed or what is there in our infrastructure currently. So this is very much important. So suppose you are working on a cloud infrastructure project for the first time, and you have created some infrastructure and you have deployed it. So it is very much annoying to go to each and every module and go through the like if I have deployed something or not. But the terraform.tfstate does that job very easily. We can go to the tfstate file and we can just check the resources, what resources has been deployed. We can also parse this tfstate file by any means, and we can list out the resources. This is fine, but to list out the resources, now comes the fun part. To list out the resources, Terraform has a very good command called Terraform State List. Before going there, let's see how can we see the state file. Now let me clear the screen. Now if I type in Terraform show, this will show me the state file in a human readable format. That is, this what has been deployed. So we can see that two resources, one is this bucket and one is this public block access. These two resources has been deployed. So the Terraform show command will show us the state file in a human readable format. Nice. Now let's clear the screen. And as I said that there is second command where it shows that to list the resources within the Terraform state. So now let's give Terraform state list. Now this will list all the resources inside the state file. So this said that this is the bucket and this is the public block access setting. So this is actually listing the resources from my state file. Now suppose I want to show I want to see an individual resource within this state file. How can we do that? So basically we can do it with Terraform show. This will show me all the resources, but what if I want to see only a specific resource within a state file? How to do that? So the command is Terraform state show, not the Terraform show. Terraform state show me which resources? This resources. So let me copy this one and then let me paste it here. Now if I give this command, so it will show me all the attribute of these resources in a human readable format. So this is the same thing. It is actually taking from the state file and it is showing me. So this is how we can see the individual resource attribute from the state file. Nice. Now let's clear the screen. Now the next command we are going to use is Terraform refresh. What it does? Terraform refresh actually takes the infrastructure currently and it refreshes the current state file. So think of a scenario. We have one S3 bucket and we have changed some properties to that S3 bucket that is deployed with our state file, not something that is not within our state file. So something which has been deployed with our state file and we are changing the properties manually in the console. Terraform refresh will take that state and refresh the state in the state file. So let me explain it. So before giving this command, let's go back to our bucket, and in the permission section we can see that currently block all public access. This is managed by our Terraform infrastructure. We have deployed this one with Terraform. Now let's change this one. Let's make it public. So we are unchecking this block all public access and save changes. I will confirm this one. That means the block public access settings should be false right now. Now let's do a Terraform refresh. As soon as we do Terraform refresh, it will refresh the state for this bucket and this settings that is deployed to our AWS cloud to our local machine. Now if I open up our workspace, I can see that there is a TF state file. This has been created. This is created with the false, block public access settings false, because in our management console, if we see in our management console, block all public access settings currently false. So it has updated this one as false, this one is false, these 4 properties as false. But it has also created one backup. What is this backup? And this backup actually holds the information about the previous state of our infrastructure. So in our previous state, the block public ACLs was true. This was true. These 4 attributes was true. But as we have changed the information in the management console, this is my current state of false. Everything is currently false. So this holds true. That means in our management console, this has been changed. But initially it was true, and now in our management console it is false. This is very much important. If we can think of a scenario that one EC2 instance or one S3 bucket that has been deployed with our Terraform, and later on some properties of it which has been previously managed by Terraform now has been modified manually in the console, and no one knows about it. So if we do Terraform refresh, we can see what has been modified, comparing it with the previous state. Now this is very interesting thing. If currently we do Terraform plan, what it will show. Now if I do Terraform plan, what it will show. So basically what it will happen, Terraform plan will again consult this terraform.tf state, that what currently there is in my infrastructure and what we want to deploy in our infrastructure. So currently we want to deploy everything, these four properties as true, but in our current infrastructure this is false. So this should show us exactly, this is showing us that these 4 properties currently is false, but our desired state, that is our desired code that is there, it should be true. That's why it is showing us currently in the management console. I can see it is false, but you want to be true. That means it will change the property from false to true. This is why the arrow sign means. That means it will change this property from false to true. So this is where the concept comes from, desired state to the actual state. The actual state of the infrastructure is false, but my desired state is the one which I am writing down as a code, which is true, but the actual state is false. If I now do Terraform plan, it will show me what is the desired state and what is the actual state. And every time Terraform will try to do the desired state instead of the actual state. So the desired state is the one that we are giving Terraform, that hey Terraform, this is my desired state and I want this property to be true, not false. So Terraform will every time look into our code base, and whatever it finds in our code base for the property, this is the desired states. And Terraform will every time try to manage the resources or try to modify the resources according to the desired state, not the actual state. Now, if I clear the screen and if I do Terraform apply, so let's go back to management console and see. Right now the block public access, everything is false. That is the current state, and it will show me that you want the desired state to be true because this is in your code. And if I give yes, it will perform the action and it will show me that one has been changed. And if I go back to management console properties and again come back to permission, we can see that block public access has been enabled. So this is where this concept is very much important. What is the desired state and what is the actual state? So please keep in mind, the actual state is the one that you can see in the management console, and the desired state is the one that you have written down in your code. And Terraform will always try to make the desired state to the management console, not the actual state. So if there is any code drift happened from the desired state, then Terraform will again modify the state to the desired one that is provisioned with our code base. This is very cool. So let's clear the screen now and let's go to the next command. So the next command is Terraform State Pull. So Terraform State Pull, it's a very general command. So it is used to manually download and output the state from the remote state. This actually works in the local state as well. So this command will download the state from its current location and output it in a raw format. So if we give Terraform State Pull, we can see that the output is currently in a raw format. So similarly, there is a command called Terraform State Push. So this will actually push the manually uploaded local state file to the remote state. So right now we are not in remote state, so we will not talk about this one more. So this is the push and pull command is very much effective when you want to do any kind of modification with a state file. But please keep in mind, this is very dangerous command as well. So until and unless you do some kind of disaster recovery with Terraform, we don't have to use this Terraform push and pull command. Now another important command I wanted to show you, the last one. Then we will move to the local execution. Remote execution. How can we store the state file remotely? Right now the state file is locally stored in our workspace. In the next part we will store the state file remotely in S3 bucket. But before going there, this is the last command I wanted to show you. Is very important. Is that Terraform state rm, that is remove. So if you want to remove any resources from the state file, if you don't want to manage that particular resource in the state file, so there is this command Terraform state remove. Then what it will do, it will remove that particular resource from our state file. So before that, let's Terraform state list. Please let's list out the state or resources there. So suppose I don't want to manage this public access setting with my current state file. So for that, what we are going to do, Terraform state rm, then the resource, and then so I am saying that, hey Terraform, please remove these resources from your state file and do not manage these resources with Terraform. So if I hit enter, so it will show that it has been removed one public block access setting from our state file. Now if I go back to our state file, we see that there is currently one resource. In the current state file, there is only one resource, and this resource is there, and we don't have the other one. But in the backup one, if we open the backup, we see that there are two resources. This is the module one, but the module we have asked Terraform to remove it from the from its dependency or from managing. So this is why Terraform has removed this particular module, and it in my current Terraform state file there is only one resource that is there, that is only the bucket. That means what it means. Now if I do Terraform plan, see, it is only refreshing the state of the demo cloud. It is not refreshing the state of the module bucket because we have removed it. But instead, it is trying to create another module with this resource. So right now, so in our state file, as it will compare the state file, so it says that, hey, I can see in the state file you have this bucket already, so there is nothing to create. But I can see in your code, that is the desired state, it needs these resources, but I do not see that in the state file. So do you want me to create that one? So the plan is to create that one. So it will try to add these resources to our infrastructure. So far so good. So if I clear this one, and now if I run Terraform apply, yes, so it will show me one resource added. In the management section, I see nothing has been changed. It should not, because it is already blocked, but the main change happened is in the state file. So it is again managing the resources whatever we have removed. So we have removed that one, but after plan and apply, it again took the resources from our code and it is managing. So this is how Terraform state file is very useful. If we remove some resources from our state file, or if we have done some modification to the resources in the management console and we don't know about it, but we have the state file. This is the state file is very much important or very vital thing, or as a backbone of Terraform if we want to deploy infrastructure as code with Terraform. Now let's move to the second part, where we will discuss how can we store the state file remotely. So we are going to store the state file in an S3 bucket with AWS, and also I will show you how can we lock the state file so that the parallel deployment can happen. So now what we are going to do, we are going to create one DynamoDB table. So that DynamoDB table will hold the lock information of the state file. So what is lock information? So whenever we are going to apply the Terraform state to our infrastructure or our cloud, as we have seen that it acquires one lock to the state file so that no one can at the same time modify the infrastructure. So right now in the locally, when we do the Terraform, when we preserve the state file locally, it will create the log file here in the local environment, and it will get deleted after a couple of minutes. So what if we want to see the log? What is the log information there? So in that case, we have to use our DynamoDB table. So in DynamoDB table, it holds the log information that who is currently locking the state file or who is currently trying to deploy this infrastructure. So in this is very important. So if we just create one resource, if we want to create one S3 bucket and we can store the state file there. Also, we can hold the log information of the state file with a DynamoDB table. So what we can do, we can first of all create one S3 bucket for our state file. So let's create one S3 bucket. So in the S3 bucket, and that S3 bucket, I really don't want to manage that S3 bucket with our Terraform. So what we can do here, we can create it manually here in this management console. So what I will give it a name as Terraform State Information, and I will create the bucket. So my bucket is created, and let's create one DynamoDB table, and for that I will use my infrastructure so that I can also show you how can we create another resource with Terraform. So to do that, let's create a module called DynamoDB Terraform AWS DynamoDB, and there we can create another file dynamodb.tf, and within that we can create resource AWS DynamoDB table, and the logical ID should be state underscore locking. And first I need to put a DynamoDB name. So the name I will be giving DynamoDB underscore maybe state information, and then I will give the hash key. So this is needed. What should be the hash key is our lock ID, and then the attribute we need to create. So what attribute? The name should be this lock ID. So this is the attribute that will go there, lock ID, and the type should be string. So in DynamoDB, in string type should be S. This is how we do that. And so in the DynamoDB table, we need to give the billing mode equals to pay per request. So the billing mode is pay per request. TF we will give this module. We will give this module as DynamoDB table, and the source is Terraform AWS DynamoDB. So this is where it will take. So from here it will take the code and to do Terraform init, because we have created one module. So that module installation need to be done. So this is done, and now we will do Terraform plan just to see what it does when we are trying to apply it. So it's showing me that one to add. So what it is trying to add? So it is trying to add this DynamoDB table, and this DynamoDB table has a hash key, and the ID is the same one, and the name is DynamoDB state information. So it will hold our state. So we will clear the screen, and what we are going to do is Terraform apply. So it will create the DynamoDB table for us. So it is asking me for one permission. As soon as I give it yes, so it is creating the DynamoDB table. Now you can see it very easily that there is a log file created, Terraform tfstate log file, as the tfstate currently is in available remotely, so locally. So the log file is created here. So I can see the resource is created. What we can do here, we can go to our DynamoDB. And in the tables, we can see the table is created. And is our log file gone? Our Terraform tfstate log is gone. That means the locking is done, the resource creation is done. This is nice. Now what we have to do, the next step is to create the tfstate file remotely. So how to do that? So to do that, I will create one file here called backend.tf. So this will hold the backend information of ours, and what it will have, it needs one resource, or it needs one attribute. So the attribute is Terraform, and then we have backend. So in backend you can see lots of other things as well. So for AWS we will use S3, and within that backend we will use a bucket, and the bucket name is, we can take it from Management Console here in S3 Management Console, and this is the state information bucket that we have created. So we will give this bucket. So this will be my bucket. And as you were, so please remember, whenever you will give bucket, it asks for region. So US East 1, this is my region, and then we will give the key. So in which name it will store the key. So I will give it as state maybe, and Terraform dot tf state. This is the file name that I want. This is the same file name that it's here, and then we have to give our DynamoDB table. So our DynamoDB table name we have to give. So we can go here and take the name here like this, and then give it here. So that's it. So this is how it will store our state file in a remote location in an S3 bucket, and also it will create one DynamoDB log. Let's check this out. Now here, what we have to do, we have to do Terraform init. So this is very much important to do Terraform init here. I will show you why. So whenever we will do Terraform init, now it will show me that, hey, you have a local backend. You already have a backend information, that is your state file, locally stored. Now I can see that you have given one backend information to S3 bucket. So do you want the existing state file to be moved to S3 bucket? this is what it is showing. Do you want to copy the state to the new S3 backend? And if yes, to copy, or no, to start with an empty state. This is fine. So we will generally give yes, so that my existing state file, that is this one, will be stored to our S3. So if I see the state file, it holds currently all the information, is it not? It holds the DynamoDB table, it holds the S3 bucket, and it also holds the S3 bucket log. So why should we create another state file into our S3 bucket? Instead, we can just copy this state file to our S3 bucket. So in that case, I will give yes. So now everything is done. So it says that the state file locking, it released the lock from the local, and it configured the backend to S3, and then I hope it is uploaded. So let's see the S3 bucket. If I refresh this one, I see one state folder is created, and inside that terraform.tf state is created. This is nice, and I can see from our local, in our local, the tf state is also there, but this is not this is the same thing. If I just open this one, I can see currently there is nothing inside of it. That means everything is deleted, and everything has been uploaded now to our S3 bucket. So our S3 bucket is now our single source of truth. Now, very much important thing, another thing I wanted to show is that suppose now I want to change this one properties, and I want to make it as false. So as soon as I make it false, we see that, and we go back to our terminal, clear the screen, and do Terraform plan. So as soon as I do Terraform plan, it will show me the changed state, and it will tell me that this is what I wanted to do. Let's see. So it is showing that my desired state is currently false. That is here. My desired state is currently false, but the actual state is true. So I will change it to false anyway, because you have mentioned it false. Now, very important thing here is to see this part. Acquiring state log, this may take few moments. Now if I go back to our DynamoDB table, if I go inside the table, explore table items, run, and then I can see one state file locking information has been created. If I open this one, I see that the lock ID has been created with the digest information. So this is very much important. So this is very much needed to see who has actually currently holds the lock for this state file. So as we have only done planning, so this is why it released the lock here. We see that it releasing the state lock, so it released the lock, but it created one entry that who has actually tried to take the lock of this state file. Now if we clear the screen, and if we run Terraform apply, and in the apply section, if we see that it needs one approval, and if we, as long as we don't give the approval, the lock or the DynamoDB locking will still be there. So if we see here, it says that acquiring state lock, and there is no release lock. That means the lock is still there. Now if I go to DynamoDB and I refresh one, and we can see that there is one new entry created, and it shows the entry that who is actually currently holds the lock of the state file. So here is the info. So ID is this one, operation to apply, info who, this is my name, this is my name, and here is the version, and the path is Terraform state information. This is the folder, and this is the file that is acquiring the current lock. And it hold, actually this is the source of truth, like this person is actually acquiring the lock. And as soon as I give it as yes, we see here in the last before the last line, releasing the state lock. And if I come back here, and if I just refresh this one, and it shows that there is one item and the lock information is gone. That means currently the state file does not hold any lock. This state file, this is not locked anymore by any person. Now another part is that why it is important. So if we think of a scenario where currently five developers are working in a project. So someone is creating S3 bucket, someone is creating DynamoDB table, someone is creating the whole network infrastructure, someone is creating the compute infrastructure. So everyone tries to deploy. Now each and everyone if tries to deploy at a time, and they can modify the infrastructure in a random fashion, and but developer A does not know what happens when deployment done by developer B. So it can happen that the code that is written by developer B is not holds true for developer A, or it is not configurable, or it is not compatible with what developer A is working into. So in that case, or in that way, the deployment is not recommended. So what it needs to do, so developer A can acquire the log of the state file and it can deploy. At the same time, developer B cannot deploy anything to our infrastructure. So after the time developer A is done with the deployment, developer B can pull the infrastructure, or can pull the state file from remotely, and it can update the infrastructure and then can deploy it. So this is why the locking mechanism is very much important, and the locking actually works in a parallel development environment very wisely. Now to show you the last part, where I will show that if anyone is acquired the lock of the state file and some other person tries to deploy the infrastructure again, it will not happen. So how can we test that? So let's test that one. So now what I will do, in the infrastructure itself, I will make it as true. So I will change it, and now I will do Terraform plan, and it shows that it will do this, it will revert it back. So I will clear the screen, and what I will do here is I will do Terraform apply. So in this terminal, I can see that it has acquired the lock. It has already acquired the lock, but I am not giving the value of yes. So it will be deployed. So still the lock is there. Now I will open another terminal. And in the new terminal, I will try to plan the infrastructure, or I will try to deploy it. So in this terminal, it has already acquired the lock. So this is developer A, and he has already acquired the lock. And now developer B tries to do it with Terraform plan. He also wants to deploy something. So as soon as he do Terraform plan, it will show an error, that the error acquiring the state lock. That means the state lock already been done, and the state lock is done by this person, and this person is currently holds the lock, and he has not been released the lock, so you cannot deploy. So the parallel deployment or the overlapping deployment cannot happen. So ask this user to release the lock, then you can again deploy. So now if I do enter a value yes, and developer A is done with his deployment, the lock has been released. Now if I go back here and if I run Terraform plan, now it can acquire the lock. Now developer B can acquire the lock and apply their changes. So as I have not done any changes, so it is showing that the acquiring state lock, but the infrastructure is already up to date, and we don't have to change anything. But the main part is that the developer A, after he released the lock, then only other can again acquire the lock and deploy the infrastructure. So this is very much important to deploy resources in a parallel environment where we have multiple developers working in the same project, so the overlapping development or the deployment should not happen. So this is what I wanted to show you about Terraform state file and how we can use it locally and remotely. Please let me know how you like this video, and like, share and comment your thought. If you are new to this channel, kindly subscribe. I will be back with another exciting video. Till then, take care. Bye bye.